Hello students, we'll continue with our multiple choice questions for the classical mechanics. Yesterday's video lecture I finished from question number 1 to question number 5. This is my question number 6, which is a coordinate system fixed in the rigid body is called as. So this is our last module, okay, where you do define what is called as the general x, y and z. This is your space coordinate system, and whenever you draw a rigid body, right, in which here I call the center as O. Suppose this I call the center, this is O dash, and then so O, x dash, y dash and z dash, right, starting from origin. So origin O dash, x dash, y dash, z dash. This system in the rigid body will be called as, or a coordinate system fixed in the rigid body is called as the body coordinate system. Right. Immediately on next, you'll have to do a problem on Euler's angle. So even there also this diagram will be of great use. So this is normal, x, y, z, center as origin, but here we have moved. So this is already x, y and z, but I moved by the angle by which I reach to the position x dash, y dash, z dash. So that will be called as the body coordinate system. Okay, we'll go to the next question. Next question is, after the second rotation theta in Euler's angles, the x2 is equal to x1 axis is at the intersection of xy and x2 y2 planes, which is called as what? So in Euler's angle we have seen that there are total 3 angles. One is phi, theta and psi, right? So this is my x, y, z axis with origin as O. Then unit vectors are I, j and k on x, y, z axis respectively, which is my normal space set of axes. Now I do the first rotation, which is phi. So I reach to the angle what is called as x1. Here also I will reach to y1, right? And in this case I say z is equal to z. So my unit vectors will be I1, here it will be I2, and here I say k is equal to I1, this is J1 and this is K, right? Because I took the rotation along the z axis, that's why z is equal to z. So which angle I moved by? I moved by the angle psi. First is angles phi, first angle is phi, second is phi. So this is my phi, right? So I reached to, after the first Euler's angle, I reached to x1, y1 and z1, but I took z is equal to z. Now next rotation, after the first rotation I finished with phi, the second rotation is for the theta, right? So which I want to check. After second rotation itself is along the x-axis. So here I will use the word x1 is equal to x2, right? But my y1 will shift to y2 and this will be my theta, right? Z also will shift, so this is my z2, and here I will say for this axis I say k is equal to k1, but this is my k2. So here I can say I1 is equal to I2. This will be G2. Right? So after the second rotation, which is theta, along the x-axis itself, I have moved x1 is equal to x2 as it is, but y1 has shifted to y2, z1 has shifted to z2. So what is the question now? After the second rotation, theta in the Euler's angle, the x2 is equal to x1 axis is at the intersection of, this is my xy plane and x2 y2 plane, right? And this line is called specially, this is given in the theory, this line will be called as, or the axis x1 is equal to axis will be called as line of node. This is a very important concept in Euler's angle, right? So once you know this definition, then you do not have to break your head. So the definition is called as, the line is called as the line of nodes, right? We'll move towards question number 8. Next question, question number 8. If a function does not depend on time explicitly and is constant of motion, its Poisson bracket with the dash vanishes. So when you define Poisson's bracket, you start off with, suppose, a function. So you reach to the expression what is called as df by dt is dabba f by dabba t plus Poisson bracket f comma h. So suppose I say that the condition given that it is a function is a constant of motion. So if it is so, then what will happen? If my function f is constant of motion, so what should happen basically? Either this term, which is dabba f by dabba t, has to be 0, or Poisson bracket with Hamiltonian should be 0. Fine. Then we said that the function does not depend on time explicitly also, which means what? Dabba f by dabba t is also 0. Right? Does not depend on time explicitly, which means this is a valid condition. So what should happen then? The Poisson bracket with the Hamiltonian will vanish. If this is the case, that f is constant of motion, both the conditions should fulfill. Correct? Either this should be 0 or this should be 0. In this condition, they say that does not depend on time. It does not depend on time. It is 0. So you get Poisson bracket of f. That function with Hamiltonian should be 0. Right? We will move towards the question number 9. Next question, question number 9. According to Dash theorem, the density of points remains constant with time. So this is a huge derivation in your syllabus, right? Where you try and prove. Okay, here you have your q axis and p axis. We try to consider area where the points are, suppose, A, B, C and D. Right? This being the generalized position coordinate, the generalized momentum coordinate. Right? You try and find out how the points are going to enter this volume element and then leave the volume element and try to find out its density. That's what is the proof all about. So what do you say over here? That first is A is Q and P. This is the motion of the particles, right? So here you say it is P dot and this should be Q. If this is Q comma P, this should be Q P plus D, right? This should be Q plus DQ P plus D, and this point should be the last point, which is Q plus DQ comma P, right? So we are seeing the coordinates of the points A, B, C, D starting from A to B, Q, P. As you move along the y-axis, P is varying, so Q, P plus DP, so this should be DP. Then when you reach to point B, this is along x-axis, that is q-axis, so Q plus DQ, so this should be DQ comma P. And when you reach to point C, this is Q plus DQ, P plus DP. So you must have studied this in the derivation, right? So it's not a big guess, I should say. So over here it's obvious that this has to be nothing but your Lovelace theorem. Right? You can see the theory for this Lovelace theorem. So this part will be clear to you. Next question immediately. Even this is very simple. Every planet moves in an elliptical orbit around the sun being at one of the foci is statement of. Okay, so I think you are studying in basic physics also, the Newton's laws, Kepler's laws and everything. So even this was in your syllabus, you are studying in module 1 itself, correct? So this is nothing but your Kepler's first law, not much to guess over here. So both these questions were that way quite simple. So we'll move towards question number 11 over here. Question number 11. The parametric equations of the curve x is equal to a in the bracket 1 minus cos phi and y is equal to a phi minus sin phi represents what? So this problem is simply your Brachy-Stowe-Kroll, which is nothing but shortest time problem. So what you do in this, suppose here you have your xy axis, this is the origin O, and you have a wire. Right? Wire is frictionless, a particle is moving on the wire and finally reaching the point A x1y. Right? So the path of the particle on this smooth frictionless wire is over here, obviously under the gravity. So you try and consider a point P and drop a perpendicular over here. Right? Then try and consider this region. So I'll say PP dash. This will be my ds. This is the smallest possible element I considered on the wire to check how will I be able to find my shortest time reaching from O to E. So what is the starting equation over here? We'll start off with the equation what is called as T is equal to integral from origin O to point A ds divided by V. Right? So what is ds over here? This is ds square is equal to dx square plus dy square. The same logic what we used earlier also. Correct? Shortest distance problem. Same we will use for ds. Correct? Try to find out the value of V. Substitute over here and reach to get the solution of this equation. Right? And at the end you'll reach to these equations. X is equal to a in the bracket 1 minus cos phi, or y is equal to a in the bracket phi minus sin phi. And these are the equations of your cycloid, which looks like this. And so on. So this is your starting point, correct? Origin. And here it will go on. So these are my nothing but equations of cycloid over here. Correct? We'll move towards question number 12. Next question, question number 12. The generating function f1 generates dash transformation. Yesterday we did one similar problem where you had discussed about generating function f2. Same logic will be applying over here for f1 also. So what is f1 basically? Yesterday I told you about the 4 functions, f1, f2, f3 and f4. Correct? Everywhere you have one old set of coordinate and one new set of coordinate along with the time. Here we are not talking about time, we are just talking about the function. So here I said the f1 function is consisting of both q's, both generalized coordinate, but one is old set and other is new set. So here the equations of these generalized coordinates are given by pi is equal to dabba f1 by dabba qi and capital Pi is equal to dabba f1 by dabba qi. So put the value of f1 over here, you get qi here also if you substitute, okay, in the equation this sign is minus, so we have to be a little careful. Fine. So when I want to differentiate this, what will be the answer? Dabba of dabba qi is 1, small qi is 1, so answer is capital Qi, and over here answer will be small qi. What does this mean? This means small pi is capital Qi and capital Pi is minus Qi. Yesterday in F2 we got both to be same, small q and capital P, both were the same. That's why we said F2 generates identity transformation. But as far as this is concerned, generating function F1 is not making identity, it is actually making the exchange transformation. P goes to Q, the generalized momentum, generalized coordinate, generalized momentum, generalized coordinate with a minus sign. Okay. Afterwards, we'll move to the next, again the first module where you had studied symmetry laws or symmetry properties. The property is homogeneity of space results in the conservation law of dash. Right? So here what we studied, that suppose you have the displacement Ri is nothing but equal to Ri plus delta Ri. Delta Ri is a small arbitrary change. Right? And we said that delta Ri is nothing but E, which was constant. Correct? So if at all you simplify this expression, that is change in the Lagrangian delta L is equal to nothing but E dabba L by dabba Ri, right? Dabba L by dabba Ri, right? If you simplify this derivation in detail, finally you reach to the expression called as summation Pi is equal to constant. Right? This part is done in theory, so we do not have to repeat it over here again. Right? Everybody must be knowing about it. You must have done this three derivation. One is homogeneity of space, right? And other two with the where you try and get, one is linear momentum, other is angular momentum, and third is energy. Right? So over here, obviously, the answer will be nothing but linear momentum. So as you say, Pi is equal to constant, definitely it is nothing but the conservation of linear momentum. So with these two theory questions, we will go to the question number 14 and 15 now. Next question. The generating function for following transformation is small p is 1 by q and small q is pq square is, we need to find out the generating function. So what is the first condition you always write over here? You write df is equal to p dq minus capital PDQ, equation number 1. Now in this case you have been given small p and small q, which means I have to find out dq. So what is my dq formula? Dabba q by dabba capital Q dq plus dabba q by dabba p dq, equation number 2. Then find out this. Dabba q by dabba capital Q will be, how much is q? It is pq square. So what will be the answer? It will be 2pq. Right? What is the next thing you have to find? Dabba q by dabba p. So this should be how much? How much is q? Pq square. So what is the answer over here? It is only q square. Right? So what is your next job now? Put the values over here. So this becomes dq is equal to 2pq dq plus q square, right, plus q square d. I reached over here. I put the value of this. I put the value of this. I reached over here. Equation number 3. Next job is multiply by p. So I can say small p dq. What is my p? 1 by q. So 1 by q 2pqdq plus q square dp. So if you divide over here, I get only 2p dq, q gets cancelled. Here also 1 gets cancelled. So I have the answer q dp. So this is my equation number 4. Then what to do? Call equation number 1, put the value over here and simplify and try to get the function. Correct. So therefore, my next step should be df should be p dq. The answer is 2p dq plus q dp minus p dq. So this is dq, this is dq. So 2p minus p will be 1p. So this is p dq plus q dp. Right? Now my job is to find out the generating function. So what will I do that? I say df is equal to dabba of that function. Correct? I need to find out the function. So I say dabba by dabba q dq plus dabba of that function by dabba p d. Right? Now we have to check which function I have to put. If at all I put pq, I can't differentiate it. If at all I put this, but here I will not be able to do it. Correct? So which means I will have to put the function pq. If I put pq, what is the answer over here? I will get p dq plus, here what will I get? Q dp. So this has to match. If this matches, which means answer is this. If you attempt any other option, either this or this or this will not match. That's the reason only for one specific function it has to match, and it has matched for the function option D, capital P into capital Q. That's the reason the option is PQ. We'll move towards question number 15 now. Next question is Poisson bracket of two functions f and g does not obey dash law of algebra. Now to do this, we'll have to first write definition. So this is my definition. Poisson bracket of f comma g is summation over I dabba f dabba by dabba qi dabba g by dabba pi minus dabba f by dabba pi into dabba g by dabba qi. If at all I write exactly opposite. Suppose I write first g and then f. What will I get? I get dabba g by dabba qi dabba f by dabba pi minus dabba g by dabba pi dabba f by dabba q. Okay. What does this mean? Suppose this term I find it similar, dabba f by dabba pi dabba g by dabba qi. Okay. So I can confidently say that this is minus Poisson bracket g comma f. Okay. Here, if at all I try and write, this is exactly same. Dabba g by dabba pi dabba f by dabba q. So here I can write confidently minus f comma g. Correct. So this is actually antisymmetry. So over here, using the property of antisymmetry, we can confidently say over here that the two functions f and g does not obey simply your commutative law of algebra. Right? Because Poisson bracket f comma g is exactly or is equal to minus Poisson bracket of g comma f, or Poisson bracket of g comma f is equal to minus Poisson bracket of f comma g. Right? So this is again the definition part, but then you need to know all the properties well, then only you'll be able to do this. Right? So we have finished yesterday 5 and today 10, total 15 are done. Just go through it. If you have any doubts, feel free to write in the comment section. Okay. I really need to know how many people are interested in doing it further. I don't mind doing every day 10 questions. Okay, or more also if the response is better. Okay, your exam is on I think 11th. So we have 2 more days. So I don't mind doing 20-25 questions more if the response is good. So any difficulty, feel free to write in the comment section. Don't hesitate to subscribe and share with your friends, because till now I have not seen any MCQs of this latest revised syllabus on the net. Okay, so please do share and subscribe. Thank you very much.